This is Brooke with PrinterBot Live, and it is 4:33, so almost on time. And of course, as soon as I get ready to do a demo, it totally breaks. So that's awesome. So let's see if I can get this to reboot. So hopefully I can. Well, so there's several things I want to talk about today. One is I've got these two printers. Are they in the shot, or do I need to move them over? I can move them over a little bit. Huh? Okay. So we've been working on the, let me refresh this page. Okay. We've been working on setting up the Simple Pros for a customer that wants to print cell phones. Cell phone cases. Cell phones would be awesome, but that's not going to happen. Cell phone cases. And I can't move them over tons, Dave. Is that relatively doable? Yikes. Yeah! Okay. Hopefully that'll work. Anyway, so we've got a guy that wants to print cell phone cases. So we've started with the 13S, and we printed some with the 0.3 nozzle, just the stock Simple Pro. And I bumped it when it started. And so those produce really, really good resolution, so you can just upload to the cloud or print via USB and Cura. But that 0.3 nozzle is so small that it takes, a lot of lines to make a thick wall. So we bumped to the high flow hot end, which is 12 volts. And that one is on this one over here. We're running it via G-code. So you can upload a G-code to the file, rename it .gco, and it'll just take any G-code. Now, this one is actually our 24 volt hot end that we put on. I know I'm going to have to restart that. I'm going to restart it. So we put the 24 volt on this one. It's just not up to temp on the bed yet. And this one is 90 watts, 24 volts. And so obviously it outperforms the other one. And the question that we had this week was, what are the actual, give us some data, and Gabriel did this for me. What are the actual stats between the 12 volt high flow, which is 33 watts, and the 24 volt, which is 90 watts? Now it wasn't an argument, but I had Sanjay from E3D when I was at Murph say, you can't really honestly say that is a 90 watt hot end, can you? It is a very polite British way. Man, it's just slamming into that. But I was like, what do you mean? It's 24 volts and it's this much. I'm going to see if I can cheat. Well, of course it's not going to print. Hold on, I need to. Dave, would you mind grabbing me a set of needle nose pliers so I can get this blurb off the end of this thing? I need to clean it. It's not actually producing 90 watts. So, it's not really 3 times as powerful. And so I came back to Carl and I said, Sanjay was saying that we're not calling this the right amount of wattage. And he goes, well, he doesn't know what he's talking about. So I was like, okay. But anyway, so I asked Carl, well, can you just give me some reassurance that this is a 90 watt hot end? He goes, it's a 90 watt hot end, Brooke. Now, how much the duty cycle and when you realize that it's turning on and off, there is some. Okay. If you measure the amps that it's actually pulling at the time, that does vary a little bit. So he goes, but it's just Ohm's law. It's just math. So anyway, the high flow is 33 watts, and I've got some data here. And if these aren't, you know what? I think it's probably too cold in here. I have the air on. I should turn that off. we were running them in a hotter room. Okay. And I think that's affecting this bed. But anyway, so we've got some data, and I just thought I'd share some of it. So check this out. These are the test prints, and these are those cubes that you can find on Thingiverse. And so this is, let's see, we did the Ubis 13S, the high flow, and the 24-volt high temp. And the difference in these, you don't have to zoom in on this. It's when you print really fast with an old printer board, you're going to get these little, on the, what is that doing? On the edges here, on the corners, you're going to get a flare. So this is a little better resolution, but for the speeds that we're printing, this isn't bad. We're trying to find how fast will this thing print. So anyway, this is the same print, 2.2 millimeter resolution, and the slower hot end, the 13S, printed at 17 minutes in that resolution, 0.3 nozzle, and the high temp printed in 11 minutes. So in that time, you have to take out the heat up time. So in the heat up time is about, for the Ubis 13S, to get to 210C, it takes about 100 seconds. For the high temp, it takes about 135 to 140 seconds. And for the high temp 24-volt hot end, go to room temperature to 210, it takes 45 seconds. So the heat up time is dramatic. So only, about a minute and a half, a little bit more, is the heat up time. But 17 minutes, 11 minutes. I think that's crazy. So anyway, that's that. We have a bunch of little samples here. I'll just give you some data and then I'll shut up. Okay, it's not sticking, which is driving me crazy. The speed at which this old printer board moves with this high temp, because you're not limited by flow. Yeah, that one's printing. That did it here. I wonder why it's not. I don't know why it's not sticking. Anyway, chalk up another failure, Dave, for the for the demo. I'll try it one more time. Yeah, I should put a piece of tape on here. You don't have any blue tape, do you? Do you have any blue tape? Can you get me some? I want to see this thing actually print. Anyway, so this one is... Oh, by the way, I didn't tell you. That was 180 millimeters a second speed. So with the G2 over there, it has acceleration. So it's going to slow down and speed up on the corners. This one doesn't have acceleration turned on. So that's why we're getting the faster times on the old printer board. Not just we can run it faster without acceleration for small prints, but it can it doesn't slow down in the corners. So it's kind of hard when you say, how fast is your printer print? Really, you have to bump the speed up, and that's what these bags are. We did various speeds. Like these were 162 millimeters a second, because we wanted to see where's the threshold for that speed and the resolution that's good enough. This faster speed does take a hit on resolution because of the corners, and we don't have acceleration turned on. So we will turn on acceleration when we start printing real cell phone cases, but the data shows every time, like this one is 17 minutes and 11 minutes, again at 162. So 162 to 180 millimeters a second doesn't really show a difference. But if you've used a printer board, we've never been a company to brag about your printing speed, so I thought it was time to just show. 135 millimeters a second, the two machines. Now we're getting really nice resolution with this. This black one is the high temp, right? No, it's actually the reverse. This is the high temp, so I was wrong on that. Wow. That's insanely good resolution for 180 millimeters a second. That is crazy. 0.4 nozzle, by the way. This one, 135 millimeters a second, 11 minutes, which is what all of the high temp did, and 19 minutes for the G2 board. So anyway, I don't want to bore you with these, but 117 millimeters a second, 16 minutes and 12 minutes. These are really similar in resolution. You get down to about 100 millimeters a second, and you start to see the resolution be good enough. I just got a couple more millimeters a second. So we got 18 minutes, and there again 11 minutes at 90 millimeters a second. And the resolution's getting better. So we'll probably end up printing those cell phone cases at probably around 90. Yeah, just two more. This is 72 millimeters a second. Oh, there's where we take the hit. 72 millimeters a second, and you got 17 minutes. And, nope. Is that right? 19 minutes for this one. Oh, here it is. 14 minutes. Crazy. Those are really good resolution, too. So I've literally never had my printers print this fast because I never really cared. But when the whole point of printing oh, there's the other one. The whole point of printing these cell phone cases is you got to print them fast because people might actually come into the store and say, I want one for my iPhone 4 or 8 or whatever. At 45 millimeters a second, which is about the speed at which I print all the time, it's 20 minutes. Is that right? Yeah. 20 minutes. And by the way, the resolution is fantastic on this one at 20 minutes. I'm sorry, I did it backwards again. 20 minutes, very, very, very good resolution. 24 minutes and 15 minutes. So I'm sorry, I keep doing that wrong. Anyway, point is, I did want to just show you that, this thing started way after that one, and it's almost about to catch up. So can you push your printers to print faster? Yes, but you really need a hot end that can handle these speeds. When I was looking at these, on the lower, on 45 millimeters a second, all three printers can print, even the 0.3 stock Simple Pro. And of course the high temp ones have no problem. But the problem is you get above 72 millimeters a second, they can all still print. But when you go to 90 millimeters a second, the Ubis 13S starts to, we didn't even bother, the difference in time starts to be so dramatic that what's the point of even trying to print fast with such a small nozzle tip? And the 13S could keep up probably a little higher, but you'll never achieve the speeds because you can't push the filament fast enough to go way above 100 with the 13S. It's a 30 watt, it has a very short melt zone because you just don't print at those speeds. But for these high flow and the high temp, which is also high flow, we wanted to put large nozzles on them and print very, very fast. So you just can't do that. You put a 1 millimeter nozzle on a 13S, you're going to have to print at like 15 millimeters a second. But with the high flow, you can print up, obviously, to, I guess the fastest was 180 millimeters a second. We went beyond that, by the way, but it just gets so ugly, the print gets so ugly, like why? We found out in Cura, you can't go above 700. 711 or something like that is where Cura doesn't even let you print faster than that. But it looks like crap anyway, so what's the point? Anyway, so we're about halfway through, a little bit over halfway through the print on the high flow on the G2 board. And like I said, this is about to catch up. So I'll let those print for a little bit, but I want to thank Gabriel. He's one of my employees. He did all this data. and we can post that. Dave, you're going to have to keep notes of what I want to post after this show. We can do it tomorrow, or like give me a to-do list and I'll do it. So I'd like to post a blog post about these results and do some pictures so people can see what we're doing. Now, one thing to note, if you're doing speed comparisons, it's best, I broke this rule, it's best to have all the equipment identical, except for it's the hot end that we're trying to see which is faster. But I fried a G2 board when I hooked up the 24 volts. I hooked it up wrong and let the smoke out. So this is a printer board, no acceleration. That's a G2 with built-in acceleration, jerk. So it's not exactly apples to apples, but this was the fastest way I could get a 24 volt hot end up to speed. Now when you compare printer to printer, you should really have the same electronics, the same hot end, the same power supply, like everything should be same. And a lot of times people say, well, this printer prints so much faster than that printer. Doing a side-by-side comparison of two completely different printers, two completely different hot ends, it's not meaningful, I don't think, to give advice to a crowd that's wanting to bump their print speed because there's so many variables. You don't know which one's going to hold up and which one's going to fall down. But since I only use my own printers here, I can get some fairly good data on one hot end versus another hot end. Now, once we get done with the testing on this, I think I'm going to, years ago I ordered an E3D hot end because I wanted to see what they were doing. Never used it. In fact, Carl came by and I just said, hey, Carl, check this out. And he was like, what are you doing? What are you buying their stuff for? And I just said, I just wanted you to see it. And he hasn't used it either. We only eat our own dog food. Anyway, so I'll let these print because they're almost done. And I'm going to move on to the next thing. Now, I don't remember if it was last week, 2 weeks ago, I told you I was going to get the Raspberry Pi, the Sensei. So I'll bring this over and show you what I did. JS. I got to open up terminal. You can go to you can do Google search on CNCJS and Raspberry Pi. There's this very, very long instruction on how to like an easier way to, if you don't work per, but if you want to run any CNC off the CNCJS, you should probably get comfortable with the program. We're trying to offer an option to ship the Raspberry Pi with the printer. So I've got the Raspberry Pi here in a case, and it's hooked with an Ethernet cable. And I've actually got the borescope, the little camera with the lights. We got that working. I'll tell you about that in a second. We tried the shuttle and found out the Shuttle Express actually, so I'm controlling CNCJS with my laptop. You actually plug the shuttle into the laptop. I was like, how do I get this on the Pi? And Nick was here, my own programmer, and he was like, you don't hook it up to the Pi, you hook it up to your computer. Because it's really just emulating keyboard shortcuts. So that's pretty cool. But anyway, so I got it running. There's a long list of instructions on how to do it, but I was like, this is going to be a pain. Does somebody have an image that's already done? And this one guy posted in a forum, he goes, just type in this command. And so I typed in, I forget what it was, but npm is like a repository of code or programs for Raspberry Pi that you just type one command and it downloads all of the things that it needs to, updates, reboots. So I did it the other day. I was getting ready to go home. I said, well, I better try that 2 nights ago. And it literally took me 15, 20 minutes, and all of that was waiting. I typed the one command, it went and got it, it started uploading. I was like, wow, this is working. it rebooted. I checked the network, found the IP address, and boom, brought up the software. Oh, they're done. So they finished about the same time, didn't they? But you saw this one failed a couple of times first on sticking to the bed, and then. So let's look. Pretty good. A little bit wavy on the corners. It's not real crisp. Same with this one. When you go fast, you get that. That's probably the belts need tightened, so you don't get perfect geometry when you go that fast. So it's a little ridiculous to go that fast if you want something high resolution. But the edges on our cell phone cases that we're designing they don't have sharp corners. They have all rounded corners, so it might be a good match. And you know, if I had a cell phone case at that resolution, I'd be happy actually. So it's promising. All right, turn that off. Anyway, so if you want to run CNCJS on a Raspberry Pi, it's actually really easy because it's just that one command. So Dave, second thing is I'll write a short post about because I had to look in forums. I want to show people how to get CNCJS on their Raspberry Pi. Now, you really need to use a Raspberry Pi 3, okay? You really should. I forget exactly why they said that. There was Node. It runs on Node. Anyway, you don't have to know this stuff, but I used a Raspberry Pi and an 8 gig, a Raspberry Pi 3 and an 8 gig card. But it controls it really, really well. And of course, I'm not going to have you stand here and watch me do terminal commands. But I was happy. The one caveat that we ran into is you actually have to tell the streaming server when you run a video camera. There is a plugin in the software. I don't think it's going to move. Oh, it is working. Cool. Yeah, it's moving. Yeah. So I'm controlling it without being plugged into anything. And I guess technically you could use any browser. Yeah, awesome. Let's see what happens when I hit homing. See if I can break something. Oh, you know what? I've got one of the axis reversed, so I don't want to do it. It's going to make noise. But anyway, so let's see if the streaming webcam is on. Yeah. Dave, tell me if you can see this. Is it up or down on the glare?
A little more vertical, like straight up and down, yeah, like that.
Okay. So check this out. See, this is the borescope. It's actually got a really close focal length. So let me rotate it. There. So you can kind of see that this itty bitty little camera will mount it. I mean, I'm going to mount mine. It's like $30 off Amazon. On this vacuum, I'm going to mount it inside the vacuum mount, probably, so that I can see the work on my screen. Now, this isn't for unattended CNC cutting, but I think it's kind of a novel approach because sometimes you're down there and you're trying to see and you can't see very well, so you could stream your video. So, let's see, what else did we do? We didn't get the PS3 controller working yet, but it may be the same thing like the shuttle. I think I need to have it just plugged into my laptop here. So I wonder if that will work. What did I just... No, that was right. So I had to download a driver for the laptop, but what I love about this is that the community has just stepped up and got all these cool things working. The next one I want to try is... Yeah, this isn't... Yeah, it's not working here. Oh, wait, is it on? Yeah, I haven't set that up yet. But the community has got all these neat little add-ons. There's even a pendant that you can put, not a pendant, but you can take your Raspberry Pi, put a little screen on it, and have a little touch screen for CNCJS. So what more could you want? Running your CNC with a game controller, a 10-key wireless keypad, of course your laptop, let's see, your Shuttle Express if you want to use the dial to jog it. And anyway, I'm pretty excited that I got that working and it wasn't that hard. So that's the update for the CNC. One other thing, we did get, we're running this with our higher powered, what's it called, power supply. So we got to figure out how we're going to do this. My thinking is I might just put it on 24 volts because I have some 24 volt cards, or G2s here. And the caveat with 24 volt on the 3D printer, the one I let the smoke out of, how about I turn that off? Is that the right one? There. The one I let the smoke out of, well, I got a 24 volt hot end, fine, but the sensor is fine too, by the way. It goes to 36 volts. But you got to replace your fans with 24 volt fans. I didn't have those. Over here, there are no fans on the CNC, so it's safe for me to run the CNC at 24 volts. So, by the way, the printer board does, the printer board, you can run 24 volts, but again, you need 24 volt fans, you need 24 volt hot end. So you could buy one of our 24 volt hot ends and do that, but you need 24 volt fans or you'll blow up the fans, and that might damage the board. But anyway, with the 24 volt power supply, stepper motors actually operate more efficiently. They can handle the voltage, and you get actually more torque out of them. So I'm really wanting to change this over to 24 volts. I just haven't done it yet because that is not one of my 24 volt versions. Ultimachine is making our electronics now, and Johnny over at Ultimachine is awesome, and he told me this week, and I contacted Alden because he designed the board, and I said, hey, I want to go 24 volts. He says, yeah, just get your caps rated up high enough. I forget how much headroom you need, but it's just the caps that we got to source and replace, and then it can be a 24 volt board. So that means that the printers, when we switch to 24 volts, it'll be more powerful, more efficient. The 24 volts is fine to go through the ribbon cable. In fact, it'll be a little bit better than it currently is for the power on the hot end. And I'm excited. So anyway, that's that. And then we also bought this box. This is just a test, but this is just a box off of Amazon, just a project box. I don't think I'm going to get too fancy with this. We have a black one. We're testing it with the white one. We've cut some holes in it just to mount it here. But what I like about this is, yes, we'll have a power plug for the power to plug into the outside. In fact, there is one here, but we plugged in this higher power. Anyway, so there will be a plug for, you got USB going to the Pi. So you could put the Pi here and run it wireless. There's actually room inside here to run the Pi and plug a couple things here. So the Pi would fit right inside there. You just have to hook up wireless. I haven't done that yet. And you could well, I guess I'd have to get power to this, so I have to figure that out. But anyway, there's room in that project box. And what I like is if you got USB going to your Pi that does with cable, all you're dragging is a power cable. So imagine a power cable like this, plugged in. Get that. Come on. Get out of there. Can't quite reach it. There it is. Okay. So imagine just a power cable plugged into the back here with like a strain relief on it, and you're only dragging around a power cable. And of course, your power cable for your router. But what that does is, by putting the box on the side here, all of the control moves with the machine, And you don't have to, it saves a little money because otherwise I'd have to put an E-chain out here that's about 3 foot in length. I'd have to run all the wire through that E-chain and then down to something that's separate on the table, like that one box I had at that one point. I like it much better right here. It's neat and tidy as long as we can get a strain relief to drag 2 cables. Then I'll just have a power strip hanging out right here on the side. Should be good to go. So that's that. That's the CNC. So what is the other thing? Okay, now I'm gonna take a sharp right-hand turn. Oh, but I did want to share with you. Check this out, huh? Look at this. Hold on, where's my old one? Pit stains and all. So I've been wearing this shirt for years because I love it. And it is really, it's getting threadbare. So this graphic, in fact, today I got my Formlabs printer out because I was going to show my son something. And my dentist is coming tomorrow, and I get to show him, oh, I need to get those out of my car. Anyway, my dentist is coming tomorrow. I got 2, I think I told you all, 2 root canals. And he did this cool 3D scan of my teeth. And he's like, I really want to know more about the 3D printers. So anyway, he got me the files, and I printed my teeth. And I was going to print them on the resin printer, but I splashed some resin on here, so guess what? Ruined shirt. But this was the old one. We couldn't sell them because we don't have any more. But this is freshly printed. This is the first one off. Now, we know that it fades here, and we know that it fades here, but that's just, what is it, curing time, or the
I think
exposure?
Yeah, it's exposure.
It's exposure.
And emulsion rinse.
Yeah, the emulsion and the so Dave's doing these, and but I wanted to wear the first one to show you this is happening. It's real. So these will be for sale very soon. That's another thing for our list to get these things up. But I'm pretty happy that we've got this. The lines are cleaner. I cleaned up the art a little bit. It's slightly smaller, but have we ordered the medium shirts yet? No.
Yeah, well, we've got medium. We ordered small.
Small.
And triple X.
Okay, so we ordered small shirts, same stuff, and triple X because we had some people say, I want small, I want triple X. So we're getting all the sizes, and we actually wait till we get the orders to do a short run of shirts, and so we don't stock 100 shirts. That was a problem with t-shirts before. To get a good price, you have to order 100 or whatever. It just got ridiculous. So good news, t-shirts are coming. All right, that's the business. Now, I did have the printer belt out to print, and whatever I did, I either plugged in the wrong Pi. I think my Pi blew up, so I couldn't run it off of that Raspberry Pi, which I might actually have stolen for this project. But anyway, so the Maker Faire, I told everybody last week, we are going to Maker Faire Bay Area, May 18th through 20-something, 20? And I'll be there. We're bringing this CNC, these printers. We'll bring the high flow hot ends and the high temp hot ends. These will just be there to see. We'll have renderings to show all of the different sizes that you can make this CNC with. We did get our extrusion in so I can make one. I've drawn it up, the crawlbot size version of this, and then there's going to be a middle size. But anyway, so we'll show off the CNC, show off our Simple Pro, and I will bring the printer belt and have it printing. So that's the update on the printer belt is, I do believe, I've been saying there's going to be an open source one that is true, and that's the one that I actually want to get ready. Now I have a printer belt here that I have 4, but I'm concentrating on one. But I've decided, $1,500 is pretty steep. So I am kind of putting those aside until I get this open source one done, and it'll be less expensive. So I want to do kits for a small one. So some people were asking on Twitter. Okay, now we're going to take a sharp left. But if you have questions, come on. If you have questions, ask them now, because I'm going to end abruptly once I get this next bit out. Maybe I can pull up a design while I'm thinking here. Okay, first thing, Adopt-a-Bot. This isn't the sharp left, I forgot. The Adopt-a-Bot 1.4, the files are on adoptabot.org. A big shout out to Jason Radford, who is actually doing what I asked. I said, people, give me feedback. And he says, hey, these holes are too small for the bars. So I designed and printed a little test piece. That's what you see right there. And that is in the files now. If you go to the Fusion 360 link, that's in the files. But this was, the first hole was the size that I have in the model. The second hole was 0.2 millimeters larger on the diameter of the bearing hole and the bars hole. So we have clamps now for the Adopt-a-Bot instead of just press fit. So it's all much better, but he was still having to drill out. So I did 3 different sizes. He tried them all, and it looks like the middle size, 0.2 millimeters larger, makes all the difference in the world. So I'm going to go through the model. And that's a to-do list. I need to make good on that promise. I need to go through the model now, resize all of the holes for the bars, all the clamps, and all the bearings, all the clamps for the bearings. And I'll resize those so that they print, and you can just put your bar in there and crimp it down. It's a lot easier to build. He did make one other note for me that I have to remember what he said. He also complained, not in a bad way, but told me that extruder mount, which is a really funky piece, it's an all-in-one piece now instead of like 3 different pieces. It prints flat on the bed, but it does not look like you could print that thing without support. The truth is you can. Now, the back of it kind of looked a little weird in the model that I published, so I whipped up a new model, put some more support pillars inside the fan area where the air is coming through to hold up, and he's testing that. So I can improve that as need be to make sure that the print without support works every time. So I thickened up some of the walls. I'm just tweaking. That's a difficult part. So anyway, the Adopt-a-Bot is continuing to get better and better, and I wanted to mention that. All right, now the sharp left, unless we have a question.
You got a couple of.
Yeah, hit me with one. Did you ever get around to designing a cable relief for the wires on the Simple Pro bed? What he's talking about is right here. The answer is no. But I have a plan of attack. So this right here is where the wire connects. It is soldered into the heat bed. It's underneath here. And we've had some people have some problems. So the part that I'm going to do is actually going to connect onto... I have to test 2 things. Either a press fit, where when you tighten this bolt down, it holds it tight in that pocket that is there. And it'll have a little Delrin piece coming out here on the plus and the play. I don't know if I have one. Yeah. What we did for strain relief was we have a little Delrin piece right here that reaches out beyond where the wires go in. And it is a spring of sorts that keeps your wires from bending hard. So I've had a couple of people, I don't know how many, but if you have the heat bed and you're running it, eventually right at the solder point, there's nothing I can do about this. We're using quality wire. We are using wire bought in America from DigiKey, correctly rated. It's not cheap wire. What the problem is when you solder the thermistor wire on the end, the solder wicks up the stranded wire, and that is hard. So you've got this, and some are worse than others, and they're hand soldered here, so, you know, some people may never have a problem, some people may have a problem, because let's say I soldered with a little bit too much solder that wicked up, that is rigid now, and then you got no solder, and it's real bendy. Well, you bend a wire enough, and it will break. So there's some... Now, how to fix that, by the way? All you have to do is... I know you don't want to solder on your machine, but some of you do. All you have to do is pop that board, turn it over, turn everything off, desolder that thermistor cable, cut it, strip it, solder it back on. So that will fix it. We've had people ship back printers that had one bad wire that broke in two when a soldering iron in about 5 minutes would have fixed it. But yes, so I will make it a priority. That's the next thing on the list. And actually Gabriel or Jonathan could do this. To have a bolt down piece of Delrin, probably a printed part. I don't know what we'll do there, but I also have a couple of holes here on the belt tensioner that we have space there. We could use the belt tensioner as the brace for that wire. But yes, get your design caps on, people, if you got a Simple Pro, and help me fix this because there's been a few people that have had wires break. And it's the thermistor wire, by the way. Very small wire. The wires that are in here, I don't know if you can see them. The wires that are in here are like this. This is running to the 24 volt hot end. But these are silicone RC car, like quadcopter wires with lots of little tiny strands. This is exactly the right power cable you would want to use. Nothing short of this. It's 18 gauge. Is that right? 18 gauge, 200C, rated for 200C, Turnigy wire. So we're using the right wire in here for the heat bed. It draws a lot of amps. And it's very flexible. It's just that solder point on the thermistor wire. So anyway, if anybody has a design they want to show me and try out here, how would you do it, then let me know. Because yes, you know what we could do is also, that acrylic could just be cut. That's probably the answer. Cut the acrylic. Make a note. The acrylic doesn't have to be square like this. It can have 2 bolt holes for a piece of Delrin to strap onto it. I don't want to require everybody get a new piece of acrylic because it's really just a spacer. That acrylic just looks neat on the front here. That could be anything. It could be wood, anything. But that's what we do. We change the acrylic design. So there you go. Glad you asked the question. You got something over the screen here. Okay, cloud updates. Oh, yeah. I got a note this morning from my programmer. Don't tell anybody, but he is setting up a server for me this weekend to test these new features that we've been kicking around, that have been promising. So I will actually get to, and hopefully some of my employees will get to bang on this private little server and test it. If you're, let me see if it works first, but if it works, I may tweet out and privately message some people if you're interested in testing. It's a test server. You're not going to hurt it because it's not connected to anything. The regular server will be running, and then when we prove that test server runs perfectly with the new features, we can cut over to that. But yeah, they are coming. The goal is to get it all live and everything up before Maker Faire, but it looks like maybe the programmer will come through a little earlier. What's that say? What's the next one? So I'm trying to create an account on PrinterBot, but it's asking for a serial. What if we have a simple metal and don't have a serial number to provide? It's a mandatory field. So the cloud only works with the G2 board and the touchscreen. So if you have an old simple metal, yeah, it won't work because we are doing several things in the cloud that are very specific to this touchscreen. And I call it the whole electronics package for the Simple Pro. So, but here's the next thing, Dave. I'm starting to have people ask me, well, I want to put the touchscreen and the power board, and I want to use this ribbon cable because they have a plus, and they want to use ribbon cable to get up to the extruder, and they could use the little daughter board to do that, and you know they have all the same equipment. So we are going to sell the whole electronics package, but it made no sense to do that until the cloud was working. So if you had a printer that was 6 inches by 8 inches by 8 inches, and I guess it wouldn't have to be 8 inches on the Z, you could theoretically hook up to our current cloud and use it right now, but you'd have to have a 0.3 nozzle on a Ubis 13S. You know, it's really tuned. This electronics package is currently tuned for a 13S with a 0.3 nozzle, and when it slices, that's all it does. So there's no point in you buying electronics until we get that cloud working with different variations of tip sizes and bed sizes. So it'll be for sale soon, but you could test it if you got the 0.3 tip
You could, if you're game and you want to buy it and use a 0.3 tip, I mean, what do I care? It's fine. We can get you a serial number. We locked that down for the launch, in the last couple of years because it only works. I didn't want to frustrate people. It's not supposed to work with anything but the Simple Pro. That's all it does right now. We're working on having it work with other printers, so then if you want to choose for that platform, you can do it. All right. Can you create multiple cloud accounts? Say if you're a teacher that wants to create accounts for students. Yeah, we have a serial number. And how does that work, Dave? It actually shows on the, no, not this one. The way that it works is on your printer, when we build the printers, we actually have one of those fancy, I don't want to lift it up. There's a sticker that you can get from this company that prints unique serial numbers on these little stickers. So we put a sticker on there and we put that exact serial number into the firmware. So we register it with that bot, and eventually we can use that to track you. I'm just kidding. We can use that to associate if we have a problem with a set of printers. We'll know when they were built, what components that they contain, and so on and so forth. But right now, it just gives you access to the cloud. So I forgot I turned that off. But on the Wi-Fi screen, on the Simple Pro, there's a serial number that's unique to each bot. And we ask people to put that serial number in the cloud. By the way, another guy that I met at Murph just keeps paying off, man. Brian Fife, I believe was his name. Really cool guy. And he said, hey, I want to help you with your G2 documentation. So we don't have that live yet, though, do we?
No.
Okay. So that's a to-do list. It's really a copy and paste. He gave us the whole document. So he took what we have on the current G2 information page, which if you did a search on printrbot.com for G2, you would find that page. But just know that in the next day or two, Brian did a fantastic job of writing documentation. He says, your documentation sucks. And I was like, okay, I'll take it. And he said, but I can help. So, I bought a G2, and there's a lot of questions I have. So between me and the knowledge in my little head and Rob at Synthetos, or Tiny G, Rob was fantastic. Got them talking, we did some research here, just combing through all my notes in the emails and stuff. And we finally have a really decent documents page that will go up on the, we could just post the PDF file that's in the email, Dave. Anyway, the documentation that Brian wrote, much appreciated to Brian. In fact, as a thank you, I sent him a refurbed Simple Pro so he can continue to play with the G2. Now, his interest was, he got it for, I think, a Plus or a Simple Metal, and he wanted the quieter operation, the really fancy, acceleration stuff, and it's nice. But he ran into some caveats, and he wanted to run it with Octoprint on a Raspberry Pi, which I know you can do, but I haven't done tons of it. So anyway, he says, well, good news. I followed all the instructions, and the documentation's accurate. What it was is there's a couple of things that you have to turn off in the settings. There's a lot of settings on Octoprint. But you turn off these two settings, or whatever settings, and it's in this documentation, by the way. And then you stop having problems, and it works. So he's like, yeah, it worked great. So he's doing a little touch screen to add to his Pi. He got the Raspberry Pi touch screen. I think I have one. I have one that I broke. That's awesome. Anyway, there's this Raspberry Pi touchscreen. It's funny because he said, well, I'm not crazy about the Raspberry Pi touchscreen. It was a little bit laggy or something about it he didn't like. And here's what he said. He goes, your touchscreen on the Simple Pro and the Raspberry Pi touchscreen, they're both bad, but in different ways. I don't know why he thinks our touchscreen is bad. It's not like an iPhone. It's not as responsive as an iPhone, but it's pretty good if you don't hammer on it and you just use a light touch. But anyway, so he's putting, on his printer, he's using Octoprint, a G2. He's adding a touchscreen. There's a little UI thing that you can get to run Octoprint from that little touchscreen. So I like that he's given back. So that's, why was I even talking about that, Dave? Was that a question or something? I don't know where I got off on all that. What's the next one? What can I do if my Z-axis falls some during printing? So give up is the first thing you can do, because you're probably not going to be able to reclaim that, where it was. You could manually move it up, what's going on here, get it to move up. But that's a sign that, what printer do you have, I wonder? But I'll tell you how I combat that. Number one, so let's say you have this printer. This printer doesn't do it, because you can see it holds its position, where you leave it. If it's super worn out, and that Z-nut is worn out, and the power is off, it sinks. But it shouldn't do that, because when you're printing, let's say on the Simple Pro, when you're printing, the motor is engaged. So the only way that it would drop is if there's something wrong with that driver, or the potentiometer or the current to the motor is set too low, or maybe you have a wire that's intermittent. There's something wrong if your Z is dropping during printing, because it should be, all of our firmware ships, the printer board and the G2 ship with that Z motor engaged at all times during printing. It won't move. Now, if you stop the print, at the end, if you don't put an ending G code, so you're printing, and then you're done printing, and you don't have a G code to move that out of the way, then in 2 minutes after the print ends, it'll dive right into that print. You know what I mean? It'll fall, gravity will take it down, and you'll have that little drill hole of the hot end cone in the top of your print. So the biggest thing is make sure you're not pausing a print for a long time. If you're controlling it manually, you leave it long enough and that Z will disengage. But after you're done, you move it out of the way. You can try turning up your pots if it's just not, it doesn't have the holding torque. I'm trying to think what bot would even do that. Not really sure, but anyway, there's not a lot you can do to regain your, not on my printers, to go back and pick up where you left off. But if you compiled your own firmware, you probably didn't put always enable Z in that compile. But all the ones that we released do indeed do that. Any other questions? I figured out a little about the speed issues using the cloud. If you slow down the speed in the materials list, it will slow it down for the first move. But as soon as you change the axis direction, it goes back to wide open. So this G2 document will shed some light on that. So there is a couple of modes. It's too much to get into here, but I'll tell you what. The materials, here's how it works in the cloud. And I don't want to say that this guy doesn't know what he's talking about. I need to look at that more closely. Who's actually leaving that comment? What's his name?
Sean Wood.
Sean Wood. Sean Wood's a good guy. Smart guy. But anyway, the materials are, there's a list, like a table, of you can add your own custom materials in the cloud. Now, it's a range of speed. It's kind of weird because it's not exactly like you're used to with Marlin. But on the G2, I forget what the range is, 50% up to, do you remember, Dave? 150 or?
No, I don't.
Yeah, there's a limit. So there's an envelope of speed. And because it's all kind of with acceleration, it's always going faster and slower, so we don't put, hard numbers in there. It's kind of vague. But you can just make it go faster by a certain percentage or slower. So anyway, but there's a couple of modes. If you're using a G-code file, there's a couple of modes that you can turn on. So homing, there's a situation that's, it's not really a bug, but it's just kind of a weird deal. If you've ever been homing and it's moving super slow. Have you ever had that happen, Dave? Where you start a print and it's moving to the home position super slow. There's actually, you unlocked the perfect combination of things that you did. I forget what it was. Brian actually talks to me about it in one of my emails. But he says, so that sheds a lot of light on why it's doing that. One of the reasons that I'm doing this cloud update is because I'm not real happy with the baked-in the way that it homes. It's a little too fast. If you heard earlier, it's da-da, it's it hits a little bit too hard. The G2 can move so fast that that homing sequence it moves too fast. It needs to move slower when it gets to the edge so that it can find that precise location. So it'll just slam into it. So you can actually control that if you are allowed to have your own starting G code. So that's one of the things that the cloud is going to help change. That will take a firmware update, of course, but it will just override. We'll eventually launch both the new cloud features and the latest firmware so that the firmware can then store the starting G code on your printer because you'll need that starting G code to be downloaded from the cloud. So there is one firmware change. But anyway, I know I rambled on that one, didn't really answer it very well. All right, so the last thing, I'll be brief since it's 5:29. I mentioned an open source go-kart. I don't remember if I had mentioned it on the show. I think I did. But it's just one of those things. I have short-term and long-term projects. A lot of my projects end up just being that, a project, not a product. And that is the case with the go-kart. So I started by calling it a go-kart, but there's several things. And like I said, I don't have time to cover all this, so I don't want to get too far off topic. But I have drawn so many go-karts in the last 2 or 3 weeks, and the plans online pretty much suck. But you really have to decide, are you going to do a small one, like for a kid, like a 3-year-old? Or, how old's Ben? 4? Dave's kid's 4. Am I going to create like a wooden go-kart that's like really slow and safe for a 4-year-old? Or am I going to do something that like me and my teenage son can drive and both be satisfied with enough speed but safety? So you go from there. And then there's all-terrain vehicles and like off-road stuff. Is it going to be on the road? Is it gravel? Are you going to try to make it cheap? Are you going to try to make it fast? You get all over the map. So here's where I'm landing after exploring all of these things. First off, I do have some designs that I can share that are far enough along if you want to build a go-kart, I actually will probably go ahead and model some cheaper, at least one, a cheap like Harbor Freight sourced because I found some great go-kart sites online. And there are even places to get pretty cheap frames for your go-kart. So anyway, I'll do a blog post. You can write this one down, Dave. Just for fun, I'll put a blog post. It doesn't really belong on PrinterBot, but it's kind of in PB Labs. It's part of the time that I spend. But there's a point to this. I'll get to it. So I'll share the cheap stuff. But really where I'm ending up is, what's the point of just doing another go-kart? There's thousands of go-kart designs out there. And I just couldn't get motivated to I always want to do something a little different, not just what everybody else is doing. So then I decided I bought a golf cart off a guy, this maker that I met. I paid $1,000 for it, and it was actually pretty nice, very fast. He had souped it up a little bit. It's 36 volts. And it's crazy here in Lincoln that we have NEV lanes. So I can go from here to Starbucks and totally legal. I have a license plate on my golf cart. It is a neighborhood electric vehicle. And it's been really nice out lately, so I should be getting that out. But NEV is perfect for electric vehicles because you're not going very far. They say most people travel less than 30, 35 miles in a day, almost like 95% of the time. Gas, my golf cart seats 2, but no one ever rides in the golf cart with me. So really, and the same is with my car. I've got a Boxster, and I'm the only guy it's a 2-seater car. I'm the only guy ever in that car, ever! So I began to think, well, what would be fun to develop as an open source project? Well, I was working on the go-kart, and I thought, well, what about an open source neighborhood electric vehicle, which is really a car? And the one I want to do is literally a single-seater. Why? Because the smaller the car is, the less it's going to cost. But it's really a glorified go-kart. So I looked online, and there's a few sites that you can find for open source vehicles. The one that's really prominent is this Tabby Evo, which is the stupidest name. Ugh, I hate that name. It sounds like a cat. Anyway. But what the cool thing about this company is they've kind of drifted. It seems like maybe they're taking a bunch of corporate sponsorship now, which is the problem with a lot of open source projects. They see that, oh my gosh, Intel will pay me $100,000 if I get on a campaign and do a video of that. I hate all that stuff. I want an open source vehicle that has usefulness to me. And by the way, in a couple of years, my son Levi will be driving age. And what is more perfect than a car that doesn't go too fast? It's capped at 25 miles an hour, the NEVs. Mine goes a little faster. It's capped at a speed, so my son, if he drove it, it wouldn't be that dangerous. Secondly, there's only one seat, so you can't make out with your girlfriend in the car because there's only one seat. Nobody else can ride with you. There's no gas cost. You know, insurance on my NEV is $25 a year. Crazy. But anyway, I thought I've always been interested in electric vehicles, and the NEV I think is the thing I want to do. So I just want to show you. I took the Tabby Evo, which is available online. I had to go to GrabCAD because here's how you know a company went. They partnered with, like, what is it, Peugeot or I forget, one of the European car makers, and they did the next generation of the Tabby Evo. It's even better. It's going to be autonomous self-driving car, which I think is bullcrap, but anyway. So they took a bunch of money, partnered with a couple companies, and they're on this whole fad of self-driving cars. Well, I want to drive my own car. I'm going to drive my own car. I don't want a computer to drive the car. I want to drive the car. But I thought, okay, fine, they're in the next generation, so let me download that model. This one's like 3 or 4 years old. So I went to the page that said download, and I went, download. And they were like, files, totally open source car. Click download, 404 error. I was like, what? Like, there's no files here? I looked at the other one, or you could look at this file. Click that. That's also dead. So they don't even have the open source car files posted on their website anymore. Totally frustrating. So I went to GrabCAD and got the file. Now, when I pulled the file down, it is huge. And they weren't helping you by, like, when we release files here now, I used to do this because I was lazy. But now I have Mark, who's like a perfectionist. And before we, like, if you look at the Adopt-A-Bot files, they are very, very well organized. Also important, if you want to do, the CNC files are going to be the same way. Post the CNC files. Did we do that already?
I think so.
Okay, make a note to check that. But we need to post the ones with the animations. So Dave's helping us with the animations. And if your files aren't organized, I mean, forget about it. You know, there's 500 parts in there. So if you don't have them organized, how are you going to find the very nut or bolt or whatever, the washer that you need to use for that one animation? Well, this car is like that. There's nuts and bolts and washers galore. I deleted tons and tons and tons of stuff to get it down to the bare chassis so that I can cut out the room needed for this 2 vehicle and make it a 1 vehicle. Bring the cost down. So anyway, I am working on this. I'm going to actually share this model pretty soon and invite people. This will be one of those messy projects where I'm going to show stuff very, very early because I need help sourcing some of this stuff because I want off-the-shelf parts. I want, I'll detail a lot of this later, but I think there's a lot of low-hanging fruit to get really far in a platform that's very inexpensive, easy to build, and here's the difference. It's already different that it's 1-seater. But the difference is I want a true open source car where the files aren't buried somewhere or removed. True open source car that anybody can build. I can stand on the shoulders of giants with guys like this Tabby Evo. It's fine with me. But we're going to change it quite a bit to be even simpler. But nobody's done an open source vehicle with open source controller, motor controller, electric vehicle, by the way, and an open source motor. So if you follow me on Twitter, I've been posting, people help me find an open source controller and motor. Well, I found an open source controller, and it's actually powerful enough to run a Tesla off of. It's crazy. This guy, Paul, I met. So I've been talking about that, and turns out several people know about Paul in the EV world. And I've talked to EV West. I've Michael down there, extremely knowledgeable. EV West, I think it's .com. Maybe it's something else. But there's a lot of knowledge coming together with not just open source hardware, but finally you're starting to see some home-built electric motors, 3-phase. I found one for $500 for the kit, and I think it's 5 kilowatt, which is like as big as like if you follow electric motorcycles, there's production electric motorcycles that don't have an engine that or motor that big. So for a lightweight car that needs to go 25 miles an hour, no problem. So this $500 motor looks like something built in a barn. The guy looks kind of nuts. He reminded me of he's an eclectic electrical engineer. Who do we know in our lives, Dave, that is like that? Carl, super smart dude. It's just quirky. But anyway, so I'm going to get together. This is the last note. A site or a blog post, probably just a on our blog, Dave. I'll use what is that? A category in WordPress that you can like click on the category and all the stuff about the electric car can come up. We'll make a new category in our blog for because Twitter isn't enough, and I don't want to put it on Google Plus. So anyway, I'll share all that stuff. I know I'm blabbering about a project I'm excited about, but the point is, once we get this platform done, I'm 3D printing the body. It'll be steel roll cage and stuff, but you can put any body on it you want it. So that's why I want to use my Big E or whatever I make to print a car body big enough. And yeah, it'll be cheesy first off, and then we'll make it better. Anyway, thanks for watching, guys. Glad you joined us this week. Have a great weekend, and we will see you next week. A little shout out to Dave. This is episode 50.
Not yet.
Not yet. Oh, we're coming up on episode 50.
Yeah.
And it's more than a year now, right?
Yeah, we've been doing it for just over a year.
So we've been doing this for over a year, and it wouldn't happen without Dave. And Dave says it wouldn't happen without you, Brooke. Well, that's true. It's the two of us doing this, and we're having fun. So have a good weekend.